Now let's use Simpson's rule to approximate the integral that goes from 4 to 6 of natural log of the quantity x cubed plus 2. And we're going to let n equal 10. So let's write down what Simpson's rule actually is. It's the integral from a to b of f of x dx, which is approximately equal to, we're going to denote it capital S sub n, which is equal to the formula delta x over 3 bracket f of x sub 0 plus 4 times f of x sub 1 plus 2 times f of x sub 2 plus 4 times f of x sub 3. So we're seeing a pattern here. So it alternates between 4 and 2 and 4 and 2. Where we get to the second to last one is going to be 4 of f of x sub n minus 1 plus the final one has no coefficient except for 1, f of x sub n, where delta x is equal to b minus a over n. And we're going to recall that x sub I is equal to a plus I times delta x. So again, I want to emphasize the notation here. We can see what's going on from 4 to 6 once we get the delta x. I think that's very intuitive. The numbers are pretty nice, but let's utilize all of our notation here. So delta x equals 6 minus 4 over 10, which is 2/10, which is 1/5. X sub I, well, we need a 0 there because our first input value is this x sub 0. So x sub 0, that means our I is 0. So our I in this formula of a plus I delta x is also 0. Our a was 4, so this becomes x sub 0 equals 4 plus 0 times, and our delta x was 1/5, and that's 4. X sub 1 is equal to a, which is 4, plus I, which is 1 in this case, times 1/5. 1/5 is just 0.2, so this would be 4 plus 0.2, which is 4.2. X sub 2 is equal to 4 plus 2 times that 1/5. And that would be, we're seeing this increase by 1/5, which makes sense, and so that's now 4.4. And if we go down to x sub 10, that would be equal to 4 plus 10 times 1/5, which is 4 plus 2, which is 6. Now let's put everything in our formula that we have. So this is s sub 10 is equal to, it's now delta x over 3, so this is 1/5 all over 3. Bracket, and it's going to be f, and x sub 0 was 4, so f of 4 plus 4 times x sub 1, and x sub 1 was 4.2, oops, 4 times f of 4.2 plus 2 times f of x sub 2, which was 4.4, plus, and we'll go all the way to the second to last iteration is with a coefficient of 4, and that would be times x sub 9, which would be 5.8. Oops, f of 5.8. And that's going to add the final input value, so f of x sub 10 is f of 6. And if we apply our actual function to this, our natural log of x cubed plus 2, 1/5 over 3 is equal to 1/15, so I'll just write that there. F of 4 would be natural log of 4 cubed plus 2 plus 4 times the natural log of 4.2 cubed plus 2 for our second term. Our third term is that coefficient of 2, so that's 2 times the natural log of that 4.4 cubed plus 2 plus second to last term was with a 4 coefficient, so 4 times natural log of 5.8 cubed plus 2 plus our final term was natural log of 6 cubed plus 2. And again, I want to go and do all my calculations in Google Sheets. You could do it however you prefer, calculator, by hand, whatever. But I do like showing, again, all the inputs, all the outputs, what exactly is going on here. If I don't see a mess of decimals, I'm okay with that, because again, I tend to write them down wrong myself. That's where I make all my errors. But writing all of this out with what we designated as our subnotation, our delta x, utilizing the formula, I think keep it very organized, and now we can go to Google Sheets. And I had some previous work on there, so I'm going to slide that over. So my function is f of x, I'm just going to put it as text up here, natural log of x cubed plus 2, just to remind myself. And then I'm going to have some x's. Oops. So I'll designate one column as x's, another column as f of x, and then I'm going to have a third column that I call the Simpson coefficient. And those coefficients, and this is why, remember, it has to be even. I don't think I wrote that on my rule. Let's go back to my work here. Did I write that on my rule? No. So that was a stipulation on this formula to be able to use Simpson's rule. N has to be even, because we have that back and forth with the 4's and the 2's, so it's not going to work if it's odd. So it starts off with a 1 as a first coefficient for the first term, a 4, a 2, a 4, a 2, and so you'll keep alternating the 4 and 2 until you get to your last term, which will be a 1. So my x's, I do start with x sub 0, which is 4. I increase it by 1/5, so I'm going to take the next cell, I'm going to add 4 plus 1 divided by 5, or 0.2, however you want to write it, and then I'm going to copy that down until I get to 6. And then I have all of my, and since I went from x sub 0 to x10, I should have 11 rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Good. So my f of x is going to be equals natural log of that input value x I have on the left of it to the third power plus 2, and it's going to autofill for me. And now my Simpson's coefficients, I'm going to keep taking those down as 4's and 2's, and you should get on the second to last row a 4, and we're good. If I had odd n, that wouldn't work. And then 1 is my final coefficient for that final term. I'm going to take my next column, my final output column will be equals the Simpson's coefficient column times the output column, f of x, and I'm going to let it autofill. You could probably do a sum product formula, but this way you kind of see all the values, and I'm going to sum all of those values. That gets me all of the decimals summed in the brackets, and then I'm going to take that, and I had that delta x over 3 in front of the bracket, and I found that that was 1/15, so I'm going to take that sum and multiply it by 1/15, and then I get my answer. So my sum of my final output column came to about 144, but then when I divided it by the 15 or multiplied it by the 1/15, which was the delta x over 3, I get the answer 9.650525584 and all of that. And they just want it rounded to 6 decimal places. So I'm going to write that down. So going back to my paper now, I could write in my 6 decimal approximation of 9.650526 for Simpson's rule.